All right, we ready? We are on section 3.3. I put a little x and y coordinate here. We know all about that. What we're going to talk about today, let's change the colors of this. We'll go green. So watch what we're going to do. We're going to draw a line, just some slanted line in here somewhere, and we're going to take a look at it. What we're going to do is talk about how steep the line is. And I've already said this word already. And what do we call how steep something is? It's the slope, okay? It's the slope, right? Anybody go skiing? Snow skiing, right? Of course, you go down the slopes, right? It depends what color you go down, whether how steep it is. You know, you go down the double black diamonds, and it's pretty steep, isn't it? You go down the little green bunny slopes or whatever the color is. What's the easiest one? Blue, maybe. Okay, you go down the blue, I think, or the green, whatever color it is, and it's the easier. It's not as steep as a slope, okay? So that's what we're talking about, how steep something is. Now, how do we determine how steep something is? Well, basically, watch. If I'm starting from here and I want to go to here, I want to find out how steep it is. This is what I do. I count how high up I go, and I make a comparison, and that's what this is. It's a ratio. It's a comparison from how high you go to how far across you go. All right? Yeah, right there. Do you see that? So how high did you go compared to how far across you went, and that's your slope. You make that comparison. Look, the bigger this number is, the up and down number, and the smaller this one is, guess what? This is going to be a steeper line, isn't it? See, if this line was bigger, you follow me on this? You know what I'm talking about? Watch. What if it was really steep like this? Then guess what's going to happen to your dotted lines? The up and down one is going to be a lot bigger than the one that's going across. Do you see that? So the steeper it is, the bigger this number is going to be, the smaller this one. The flatter it is, guess what? This is going to be smaller, and the one going across is going to be bigger. You with me on that? What we do is we call this the rise over, you remember that? The run, yeah, you remember that. So, and we use a letter for slope. It's kind of weird that we use this. I looked it up one time on the internet. Dean, you with me? All right. You want a less comfortable chair? Would that make it better for you? Okay. You don't want to give up your chair, do you? Good. All right, let's talk about the letter that represents slope. You'd think you'd put S for slope, wouldn't you? S equals for slope, but they don't. What letter do they use? Do you remember? M. It's kind of weird. A little random, isn't it? Okay, but they actually do. I think there's debate. Really, there's a lot of information. You wouldn't believe how much information there is online about this topic. But there's like debate whether it came from this word or that word or whatever. But I think the consensus is that it came from a Greek word, and I think I forget exactly what it was. It was like, I don't know. I can't even make it up in my head. But it started with an M, and it talked about like a mountain. You know how it's steep and you go up a mountain. It kind of derived from that. So it talked about how steep something was, and it was some Greek, or not Greek, but Latin. Sorry, not Greek, but it's some kind of Latin word. But anyway, we don't care. It's the letter M. That's what they use for this. And we're talking about a comparison. When I make a comparison or a ratio, it's a fraction, isn't it? So the slope is equal to the rise over the run. Now that's a nice easy way to say it. Let's get a little bit more technical on this. Which direction are we going up and down? Is that the x direction or the y direction? Up and down is the y direction. And so I could say that this is like y1, and I'll call this y2 as far as going up and down. Are you with me so far? So what I say, I call this the change in y. Talk about the change. We've talked about when we did the distance formula. Remember doing distance formula at the beginning of the year? We talked about, like, if I start at the 2-mile marker and I'm going to the 8-mile marker, okay, what is the change in the distance that you traveled? What'd you do? You subtracted, didn't you? You went 8 minus 2. Agreed? So that's what we're going to do for rise over run. It's the change in the y. Now watch, I'm going to write another way to write the slope. This is kind of weird. It's a Greek letter. It looks like a triangle, but it's actually a Greek letter of the alphabet. It's called delta. All right? And this is one that we use in math a lot. We're going to start introducing every once in a while some Greek letters to you. And in math, especially upper level math, they use tons of Greek letters. We call this a delta. It looks like a triangle, but they call it delta. And the rise is up and down. Okay, it's on the y-axis, so we call it delta y. It means the change in. Jot that down somewhere. I didn't leave myself very much room, but you jot it down. Delta, it's the letter delta, but it means the change in y. The change in y. Over What do you think? The change in what? If this is up and down, this one's across, so which way is this going? In the x direction, that's right. So this would be like x1 and this would be x2. You with me? So this would be the change in x. So the delta y over delta x. Now I'm not going to refer to it like that all that often, but I just wanted to throw it out to you so you see it, because later on when you start taking more math, you're going to be thrown a ton of these Greek letters. You're going to see that letter delta and that phrase, the change in something. All right, so I just want to introduce it to you right now. I'm not going to make a big deal about it, but I will do this. Let's do one more thing for delta. This is basically the same exact equation as this. What does it mean to the change in something? When I went 8 minus 2, right, that was the change in the distance from the 2-mile marker to the 8-mile marker. So what do you think the change in y is going to be? What am I going to do to those two y's? Yeah, I'm going to subtract, okay? Now, a lot of books say y2 minus y1. It actually doesn't matter as long as you do the x's in the same order as you do the y's. If you look in the book, it probably does say y2 minus y1, but I'm just going to say subtract the y's. I just like to keep the 1 first, the 2 next. Does that make sense? So that's the change in y over the change in x. What do you think the change in x is then? x1 minus x2. There it is. That's your formula for slope. That will tell you how steep a line is. Let's talk about this real quick here. If I have, let's do a different color. What if I had, let's just talk about the green one right now. Look at this. If I'm going to rise, which direction did I rise? I rose up. So what do you think up is as far as positive or negative? It's positive, okay? And what if I ran to the right? See, I started here, I went up, and I went to the right. So that was positive. So what kind of slope is this line right here? It's positive. This is a positive slope because I went positive over positive. Some people say, well, I could go rise this way and run this way. But watch. If I start here and I go this way, which way did I go? I went down, which is negative. You're like, oh, that's going to change my sign. But is it? Because which way did I run? Negative. What's negative over negative? Still positive. So tell me something about this. It's a positive slope. Sometimes they'll do this. Now don't laugh at my picture. Well, you can laugh if you want because it's funny. Because I can't draw worth anything. That's my car. Alright? Looks like a minivan. Alright, so anyway, there's my car. What's it doing? From left to right, is it going up the hill or down the hill? It's going up the hill. So what kind of slope is that? It's positive. Do you follow me? It's positive slope. What if, let's do this. What if we had a slope like this? Yeah, that's going to be a negative slope. And let's just, different line. Okay. Watch this. If I'm starting at this point and I want to go to this point right here, what would I do? I would go down, right? You always go the y direction first, and then I would go where? To the right. So which direction is this? This is going negative, and this, I went to the right, so I went positive. What's a negative over positive? Okay, it's negative. So think about this. You're in a car, all right? Here's my cool car. I don't know how cool it is, but anyway, what are you doing? You're going what? You're going down the hill, right? From left to right, you're going down the hill. Follow me? So this is a negative slope. So anytime you see a line slanted like this, it's a positive slope. Anytime you see a line like this, it's a negative slope. We good with that? Pretty simple. All right, let's do an example real quick here because we only have just a few more minutes. Let me get rid of all this mess. Let's draw another x and y axis. Let's make it black. Okay. Okay, there's my y-axis, there's my x-axis. I tell you what, I'm not even going to do that. I'm just going to write the points down. So, let's see. I'm trying to find a good example here. Let's just use this one. Okay, what if I had a point -1, -2, and I had another point 3, 3. Now, we've done a couple things with this stuff before, haven't we? We found, what, the distance between them. We found what else? What is it? The midpoint, right. We found the midpoint. Okay, this time we're doing something different. This time, it doesn't say to find either one of those. What do you think it says to find? The slope. Okay, so find the slope. Let's just jot the formula down. Okay, it's y1 minus y2 over x1 minus x2. A lot of people get this mixed up. A lot of people put the x on the top because they're thinking x always comes first, that goes on the top. But remember what this is. It's what over what as far as the R words. What is it? It's rise over run. Rise is in the y direction, run is in the x direction. You with me? So let's put this in here. So let's subtract the y's from each other. It doesn't matter what order you subtract them in, as long as you subtract the x's in the same exact order. All right? You understand that? So let's just take the first one minus the second one. So it's going to be negative 2 minus 3. So I subtracted the y's from each other. Everybody see that? Subtracted those. Now you take the x's. Subtract those. Make sure you subtract them in the same order. If you don't subtract them in the same order, your sign will be different. So I went the top one minus the bottom one. I'm going to do the same thing with the x's. So it's negative 1 minus 3. Let's figure that out. That's negative 5 over negative 4. We don't keep it negative over negative. How would we write that?
1 and 1/4.
No, we wouldn't write it like that. What have I said? I've said it over and over again. I've gotten pretty heated about it too. Don't change this stuff into a mixed. What am I calling it? A mixed number, right? Don't change it to a mixed number. Keep it improper, especially for slopes. Especially for slopes. Do not change that to a mixed number. Keep it an improper fraction, because this tells you how far up you go compared to how far across you go. All right, if you put it as a mixed number, you won't be able to see it as easily. All right, keep it improper. I know, look, your elementary and your middle school teachers done a fine job hammering into your head to change impropers to mixed numbers. I see that. But in algebra and in geometry and upper level, a lot of times, not all the time, but a lot of times, many times, it's way better to keep it as an improper fraction, okay? Let me try to break that from you, okay? And your teachers have done a great job, because I see that all the time, all right? Let's talk about this real quick. We got like probably 30 seconds, who knows. Let's do this. We talked about positive and negative. Let's talk about this. What if you had a line that just went horizontal like this? Now, let's take a look. Let's look at the rise and the run. Okay, watch. How far did you rise? 0. And how far did you run? Whatever. Let's just make up a number. Let's say 3. Is that all right? What's 0 divided by 3? So what is the slope? Hold on. What's the slope of a horizontal line? Let's do one more. Let's do one more. You have chapel. They'll give you a little extra time. What about this? What about from here to here? To get from here to here, what's your rise? Well, what's your rise? Just answer one question at a time. What's your rise? Let's say 3, okay? Now, what's your run once you get to here? It's 0. So what's anything divided by 0? Okay, it's undefined. Okay, it's not 0. It's undefined. Put it in a calculator. Put anything divided by 0, and you're going to get an error in your calculator. That's undefined. Let me give you a few little problems to work on. We took a little longer answering those questions at the beginning of class, but I think you should still be able to do most of these. It's 3-3. It's page 191, 192. And we're doing 13 to 39, just the odds. Okay, just the odds. Everybody hear that? Okay, 13 to 39, just the odds. All right, that's it. See you in chapel.